So as we move into this idea, yesterday we talked about things like number of turning points and behavior, when a function is increasing or when is it decreasing. So let's just shout some of these things out and watch how quickly we, without ever really seeing a graph like this before, can take a list of probably 12 to 15 things, and I can pretty quickly name a bunch of characteristics. Case in point, yesterday we talked about how many turning points a function has. Raise your hand if you can tell me how many turning points. Just pop it up high, don't shout it out. How many turning points this has now? Use the hand that you're raising to tell me the number of turning points this has. Okay, why is it 2, Ethan?
Because the turning point is when it changes from up to down or down to up.
Yeah, I'm going to use the phrase increasing to decreasing, but love it, right? This is originally what? From here to here? Okay, why decreasing? Why can't you say, oh, look, it's increasing? I have to read the graph how?
Left to right.
I have to read the graph left to right. So this is decreasing. As soon as you heard Ethan say it, as soon as it changes to increasing, that's say the phrase, turning point. Then it changes again, that's 2. Right here, write the number 2, please. There are 2 turning points. Now, anytime I have a turning point, I have what we call a maximum or a minimum. Now, that's not terribly surprising, probably. If I were to talk about this, give me that order pair according to what's on your paper. What is it?
Negative 2.5 and
Well, take it off your paper. Negative 2.1, negative 5. Okay. So, to be clear, by definition, let's add this off to the side. A relative minimum is a point where there is a change from what to what?
decreasing.
Good. Decreasing to increasing. Now, it's not like yesterday, we're not writing down a ton of things, but we are going to write a few things down. I have a relative minimum at negative 2.1, negative 5. But if I have a turning point, the way Ethan explained, I have, for every turning point, a relative, being relative on a certain part of the graph, maximum or minimum. So here, which is listed on your graph as 0.758, I have a relative, take a guess, maximum. Now, if we were to define that, you would tell me it's a point where there is a what? Good. Change from, louder, increasing to decreasing. Okay. So I can then list this, and already in a short amount of time, I have taken this idea of turning points, identified those more specifically here. Now I want you to see there are actually some things that you already know without even saying, which we will next week. Next week I'm going to say, hey, look, this is a cubic, right? But right now I'm just giving you a graph, I'm telling you it's a polynomial, and I'm saying let's find these characteristics without going into it much. But don't you know the domain right now? Yes. Now, I don't know if you heard Ethan's comment before, but here is the good news. You know how the domain of every quadratic was? For the love back there, people. What is it? I swear, Amanda keeps her hand over her mouth just to like, you cannot make me say this. What is the domain of a quadratic? Thank you. For every domain of a quadratic, remember we said yesterday, a quadratic is a type of what? Give me a word from yesterday. Right, that's like ages ago. No. A quadratic is not a type of line, in case anyone was confused. It's a type of what? Polynomial, right? The whole point of yesterday was to transition into these polynomials. If you're with me on that, say yes. Okay. So as we transition into polynomials, a quadratic is a type of polynomial. And one more time, the domain of any quadratic was? That's also the domain of any polynomial. Because if you look at this, Domain means all the possible, say it. X's. Is there any, put your pencil all the way up here, right now on your paper. Draw it through. Is there any point at which I don't have a y value? No. Is there any place at which I have to pick up the pencil because I don't have something there? No. That is my domain of negative infinity to infinity. So good news, even if you didn't get it on this test, it's coming again. What's my range of this?
Negative infinity to infinity.
All right, now, we have not talked about the technical range of a cubic. But why would you still be able to give me that proper range? Why would you be able to give me that proper range, David?
It starts up and ends it down.
Okay, that's an excellent answer. And behavior starts up, ends down. You with me on that? Okay, so it starts up at what? What is that? And goes all the way to down, right? Starts high, ends low. Therefore, it's going to cover all of my possible y values. Easy enough? Okay. Now, therefore, the phrase absolute means most. Well, what is the highest this goes? Infinity. So therefore, we say there actually is no absolute max. And guess what? We're going to write for absolute min? None. Now, if there was one, you would put the ordered pair.
What would happen if you put infinity and negative infinity on the test?
I would take off half a point. Good question. Because by definition, if you say the absolute max is infinity, I could say, oh, you're wrong. It's infinity plus 1. Does that make sense? Like, there's no official maximum, because I could always top whatever you give me. Now, I'm going to jump to a couple things. First of all, at the very bottom of the graph, I do want to list the end behavior that David just gave us. Now, we're giving a pretty cheap explanation of this now, but do you remember what he just said a minute ago? He said, he gave it to us. Good, say it louder, Jonah.
Up then down.
Up then down. Notice he gave it from left to right. I'm going to start using a little bit more technical phrase and saying it starts high and ends low. So we're going to transition in language. So we start by saying up, down. Starts up, ends down. And now we're going to start to use slightly more technical, which still isn't super technical, by saying, hey, this starts high and ends low. In the meantime, then, we're going to fine-tune these final characteristics. In order to have turning points, we have to have changes from increasing to decreasing. Take your pencil, please, put it on the top of your graph. By definition, this is doing what? Okay. What? Do you remember what we wrote yesterday for the definition of decreasing? It's when the what? When the x values are increasing and the y values are decreasing. So here's the thing. If I'm going to list the time that it's decreasing, there's no point listing the y values because by definition, the y values are decreasing. Agreed? So the question is, when is it decreasing? So we're going to reference it by x's because the y's are understood. X-y's, how far is that? Negative infinity. Okay. When does it stop decreasing? You got it. Now, does anyone need me to say again why we list it like that? Okay. So, by definition, decreasing means the y values are going down. So as soon as I start to list like the when, it's already understood what the y values are doing. So instead, I don't need to list the y values because I already said they're decreasing. So the question then becomes when, which is which x values cause the y values to be going down. Is that the only time things are decreasing? No. When does it start decreasing again? Okay, so do you hear what Emily gave us? She gave us the what? X. Because by definition, it's already understood the y values are going down. So the x's start at 0.75, and for how long will those y values decrease? You got it. Now, sometimes this is the harder part a little bit. When is it decreasing? Or sorry, increasing? Colin. to, yeah, perfect. Whatever's stuck in between. See that little gap from negative 2.1 to 0.75? There's your increasing. All right, pop your hand up if you're decently okay with it. We're going to work on this all period, so if you're not great with it, that's okay, yeah. All right, so the last thing we need to deal with is these final three things. They all go together. So we're going to deal with zeros next. What is another word for zeros? Yeah. Just x. Okay, so by definition, it's just the x-intercept. Okay, so give me the zeros or the x-intercepts of the graph. Look on your paper. They are at -3, -1, and 2. Now, I did not list the ordered pair. Why is that not inherently necessary? Because it's understood, right? I'm graphing a 0, and so a 0 is a 0. Okay. So I'm going to erase the increasing, decreasing part, and then we're going to focus on the positive, negative part. Whoops. Okay. So I have a 0 here, here, and here. Now, think about what the word positive means. When I think of the word positive, what do I think about? That's deep. Things that aren't negative, yeah.
Whole numbers.
Okay, what else? Anything greater than 0. Okay, so I want you to take your hand, and I want you to place it on top of the graph where the graph is greater than 0. Just take your hand and cover up the part where the graph is greater than 0. Where is the graph greater than 0? Okay, so here's the question. What do I mean by this? It's positive, so I saw a couple different answers, so let's clarify. It's positive when my y values are positive. Does that change your answer? Does that change what you're covering up? If we talk about negative as in where the y values are negative, if I'm covering up the part where the y values are greater than 0, say it out loud. Where is that? Above the x-axis. You got it. So it's positive here and here. Now, we're going to give the when, and we give the when according to what? X. All right, you ready? When is this positive? Can anyone give me a decent attempt at this? Want to try, Colin? Just give it a shot.
Would it be from negative?
Love it. Okay, so let me pause there. He's saying, look, this whole section is positive. If you see that, will you raise your hand? Good. Okay. Can you give me the next one? Someone else says Colin or Emily. Want to try, David? -1 to 2. Perfect. Why? Because this whole section there in black, right? That whole section there in black is above the x-axis. Got it? Okay, now, negative is just typically, not always, but typically all the other stuff. Give me a negative interval. Someone I haven't heard from yet. Give me a negative interval. Yeah, Sarah. Awesome. -3 to -1. It's a section that is what? The x-axis. Below? Who's got the last one? Want to try it? Abby, want to try it? 2 to infinity, right?
Okay.
Now, it is
yeah.
going down, but I'm answering for the x values.
Okay.
2 to infinity, perfect. Okay, make sense? So, now I'm going to get you into groups, and we're going to work through number 2. So look at number 2 for me.
I'm so tired of having to move all my stuff.
It's like an inconvenience. You know what? Since it's Friday, and it's Fun Music Holiday Friday, obviously.
Biscuit? Yes.
The Limp Bizkit version of holiday music, yeah. You may sing, you may work with people around you, okay? So, can we see, how long do you think? 10 minutes?
Right,
Motion carries.